So, with our rabbit, right, with our fox, right, let's go ahead and just go over what the... Oh, come on, for the love of God. It was there a second ago, right? Are you going to give me this trouble all semester? Hope not. Times when that's annoying. VGA is more reliable than HDMI. Okay, so let's go ahead and go over what the fox does. The fox basically says, "Hey, can I see the rabbit now?" False. It also has these variables. Have I seen the rabbit? Can I see the rabbit now? Set to false initially. And it keeps track of the distance, direction, and current direction. You need to keep track of none of those because unless you're going for a really, really, really specialized strategy. Predator code needs this kind of memory. Prey just needs to respond to the presence of a predator. Okay? So what the fox does is says, "Hey, can I see the rabbit now?" It says, "Right now, it's the beginning of my move. I'm going to check if I can see the rabbit." So I'm going to assume I can't see the rabbit, and then I'm going to see if I break my assumption. So I'm going to look around. Now this bit of code is definitely something you can use. For int I is equal to 0, model.min_direction, I less than or equal to model.max_direction. And I suppose I should make a comment here about my font choice. Right? Hopefully you've noticed that this is not normally a key you can use. And all that is that I'm abusing ligatures, which is basically says that, hey, if I've got these two symbols together, so that's just a font choice. There's a couple of fonts out there that does this. This one's Fira code. And I just find it easier to read, right? Notice that the double equal sign is actually equal is combined into one big fat equals, and the plus plus are just combined like that. So it's exactly what it looks like over there. So I say if I'm looking in direction I and I see the rabbit, then I'm going to set it to true. Really, the for loop and the if statement is what we really need for our code, and I'll get into that in a second. So if I have seen the rabbit, so if I've detected it and I've tracked a distance, if I'm further away from if I'm not on top of the rabbit right now, or not on top of where I saw the rabbit, I'm going to subtract 1 and move directly towards the rabbit. If I can see it, I move directly towards it. Right? If I have seen the rabbit, I'm going to move it directly towards it. Note that's have seen rabbit, not can see rabbit now. If I have seen the rabbit at some point, I'm going to move towards its last known position. If I can see it, I'm going to move directly towards it. If I can't see it, but I have at some point, I'm going to move towards where it was because it'll probably be close, right? Not in the opposite direction or something. Otherwise, if I got to the point, right, if the distance to rabbit is greater than 0, well, if it's equal to 0, I've got to the last known location of the rabbit, I can't see him. Now I'm very confused. Where did he go? So so basically, as soon as it sees a rabbit, it's going to track the rabbit to where it last saw him. And then it's going to say, okay, I went to where I saw the rabbit. I thought I saw him, but I guess I don't. Have seen rabbit is equal to false, and then current direction is equal to a random direction. Okay? So if he's not moving towards the rabbit, then what he's going to do is that he's going to try to move in the current direction. And what this block of code does, essentially says, if I'm the fox, I'm just going to pace this way until I hit a dead end. If there's an obstacle in the way, that's what the if model.turn current direction 1. So model.turn, very important, right? Model.turn gives you these 45-degree angles, right? Model.turn, if this is current direction 1 is a 45-degree turn clockwise. -1 is a 45-degree turn counterclockwise. So current direction 1 is towards that direction, but this way. And notice there's also the can move function, also very useful for you to use, which says, can I move this way? If I can move this way, so it says if I can't move forward, I'm going to try to move this way around whatever obstacle there is. if I can't move this way or this way, I'm going to try to move this way around the obstacle. And if my 4 directions are all blocked, right, I'm trying to go forward in one of these 3 directions. But if I can't, then I'm going to just grab a random direction and pace the other way. Right? So basically, he's going to be bouncing off back and forth at random directions. Just trying to, but he's going to be moving back and forth. Why is he moving back and forth? Because he's looking. Right? The prey, on the other hand, best to stay still. So, kind of where I was hoping you would get yesterday is this point, which is default. My default move is stay still. Right? So, what we can do then is that we can kind of use what we saw from the fox, which is learning how to look around. For int I is equal to model dot, and let's remind myself what it is, min direction, all caps, with min direction, assuming I can spell it. I is less than or equal to. You want the equal to because you want to include model dot max direction. Okay, and then I++. Okay, and now we can look around at the fox for the fox by just simply saying, hey, if look I, and you might be saying, well, there's no look function. Well, remember, rabbit is an animal, and thanks to inheritance, I get the animal's look function, which is what the fox uses. If look is equal to model.fox, so if I see if I'm looking around and I see the fox, I know that the fox is in direction I. And this is dumb code. This shouldn't really work. This won't really give you much survivability, right? Which is, hey, if I see the fox, return model.turn I 4. I think that would work. Let's go ahead and compile it. Okay. And let's go ahead and see what the results of this is. And then I'm going to let you get to work. But I wanted to get you up to this point. So let's go ahead and run this. So here, let's go ahead and speed this up. I think we might get lucky here just by staying still. Let's see. Oh, nope. So notice that the rabbit moved away. And now it's no longer moving away because it has no place to go. Right? So this isn't very, so running away is great until you hit a wall. Right? And so basically as soon as you see you, if it's not endgame, then you're going to lose. So let's try this again. An experiment. What if you tried something else? Like, so notice that this was moved directly away from the fox. And actually, I'm going to leave that to you. Experiment and see what happens if you try moving in a different direction. Maybe perpendicular to the direction or diagonally away. And then throw in maybe some can moves. And the reason this might be successful is because, remember, these terms are not simultaneous, right? Fox moves, you move. Fox moves, you move. So if you're staying still, fox moves into your line of sight, you can move out of his line of sight before he even sees you. Right? So this is where I want to be. Now, some administrative announcements as terms, right? We don't have class on Monday, but if you have any questions, just feel free to email me over the weekend. If you feel like that you're not going to have this done by midnight on Wednesday, just send me an email and let me know. I generally say, hey, if I get one email, then that's 5 people who haven't emailed me. So that's how I generally count how many students need an extension or whatnot. And that lets me know, okay, do I need to extend the assignment? So I want you to watch the videos for this week, and for next week, I want you to watch the videos on array lists so that you guys understand that. I'll give you guys some more homework then. And let's see. We'll also have our first quiz on Wednesday. It's not anything you really need to study for, other than to review the first week of videos. About polymorphism, what can extend what, right? What can so basic stuff that you. But for the most part, it's meant to show you, okay, this is the way quizzes are going to work in this class. There's going to be a lot of credit just for showing up and hitting and taking the quiz next Wednesday. Okay? So it's nothing to really stress out about. Okay? And the quizzes, I'm going to try to be fairly constant with them. Quizzes also include in-class exercises that we'll do occasionally. So with that, most flipped classrooms like this one, it'll be like 10 or 15 minutes of me boring you to death, and then you guys can work. All right, so I'm going to go around and try to hit every group. Not physically, though. That would be mean. And see where everybody's at, and I'll try to also get questions, specific questions answered.